very low stratocumulus where we are. That's about a 2,000 foot ceiling, and here's how it looks on the surface map. You can see this blue area from East Texas all the way into Mississippi, Missouri, and even going all the way to the East Coast. It's all part of a continuous band behind this potent storm system in the southeast. Before we take a look at that, let's check out the soundings and correlate what we see in the video with the Skew-Ts. And there you go. That's going to be a representative Skew-T for the opening clip. You can see that frontal inversion is way up there. The top of the cold air at about 10,000 feet, 3 kilometers or 700 millibars. And yeah, that's about 10,000 feet or so. In the lower half of the cold air mass, it is humid. The moisture and temperature lines are very close together. So why is that? The winds are out of the north. I mean, there's not an ocean to the north or northwest of here. So where's that moisture coming from? The answer lies in the fact that there's a lot of air mass modification taking place. Another factor is that it was raining yesterday, so there's a lot of residual moisture in the air mass. Now, the dew point temperatures in the low levels, in other words, how far left or right it is, that's going to be a function of how much moisture there is in the air mass, the true amount of water vapor. And 30s is about where it would be in the southern U.S. after a rainy weather event in the wintertime. If we had an Arctic outbreak, we would find that line way over here, indicating dry conditions with a Canadian origin. Now, relative humidity, that's a function of how close the temperature and moisture lines are together. That's a function of both what the ambient air temperature is and what the dew point is. And in this case, these lines are very close together because with very cold conditions near the surface, the air mass does not have much capacity to hold moisture. And there's just enough moisture in there to where we're pretty much near that capacity. And with that bit of instability, a cold layer over a warm surface, that means we've got unstable conditions in the lower atmosphere, and we're quickly going to saturate some of that moisture, and it's going to stratify beneath that inversion. And the result, overcast stratocumulus and a dreary day. Here's a quick look at that system there in the Atlantic states. We've got snow coming down across much of Pennsylvania and also Ohio. Looks like that rain-snow line is right there in West Virginia, extending right across the Washington, D.C. area and just south of Philadelphia. However, that rain is lurking to the south, and that's likely going to spread inland slightly as the warm air advection pattern sets up and that low tracks up the coast. Here's where we're at right now, and let's watch this system develop. Now, the key things that we're going to look for on this chart is going to be the actual low pressure system there in North Carolina. Also, the pressure gradient through here. You can see all those black lines indicating a strong easterly gradient. So the winds are going to be blowing sort of in that direction right there. And we're also going to watch the progression of the rain-snow line located right about there. I'm not too worried about the purple. It's mostly the division between the blues indicating snow and the green indicating liquid precip. And one final thing that we're going to look for is the thickness lines. There's the 540. That's traditionally used to differentiate snow from rain. Now you can see that it's sitting a little bit north of the rain-snow line, and that tends to be the case. This isn't a hard and fast rule, but that will get you in the ballpark. And what we're going to see here as that low approaches is these thickness contours starting to move north as the warm air advection pattern sets up. However, that will be checked to a certain extent due to the adiabatic cooling as we get that strong lift taking place northeast of the low. So let's put it into motion and see what happens. We're going to advance this up to about 9 p.m. So there goes that low moving up the Delmarva into Delaware itself. And yeah, that brings us to 9 p.m. Now we can see that 540 line has advanced just a little bit, not very much, but there is strong warm air advection taking place nevertheless. And so we're getting a convectively unstable pattern. We're going to expect to see showers and maybe even a few thunderstorms mixed in. We can see that the rain-snow line has advanced up into the southeast counties of Pennsylvania, and likely due to the sounding profile, there's going to be a mixed bag of precip. Now we can drop this sounding right into that purple, and we can see that the subfreezing layer extends well up above 1 kilometer. This is very deep cold air. So any precip falling into this, even if it melts, will likely be in the form of ice pellets. And it does look like there is a slight area of above freezing conditions right there, so any snow falling into that layer will likely melt and then refreeze on the way down. And if the snow does not melt or melts only partially, you'll get ice pellets mixed with snow or only snow. So the end result for those southeastern counties is going to be ice pellets or ice pellets mixed with snow. Now to support freezing rain, we need a shallow layer near the surface that's below freezing, and I'm not really finding much of that poking around on these soundings. That looks very deep cold air, southeastern Pennsylvania, around Philadelphia. We can see some warm air near the surface, so warm air advection really dominating effects near the surface. And I'm just not finding profiles here that are supportive of freezing rain. When we get back into those purples, now we've got a column that's too deep for freezing rain, and that's more supportive of ice pellets and snow. So I think the main hazards here are going to be ice pellets and heavy snow. So moving forward, you can see that low tracking up through New Jersey overnight and ending up around Long Island around dawn. Now, the other thing we're going to be watching for is very strong winds. You can see the gradient really tightening up there around dawn. And we don't have charts past 18 hours. So for that, we'll go to the NISL WRF, and I've drawn the wind plots on there. And you can see that overnight the winds are picking up to about 25-30 knots on Long Island. And then we can see the low off the New York coast right there, New York City, around 6 a.m. And I'm seeing about 45 knots there just offshore. And then it looks like some of the heaviest winds are just after dawn. This looks like about 40 knots just along the south part of Long Island. And then things should start easing off there as the morning goes on. You can see New York City there down to 20 knots. And that puts most of the heavy winds in eastern Long Island around midday. And then we get the cold air flowing in. Now here's one interesting perspective we can use to see what's going to happen in New York City. We can go to this TAF panel. And what I'll do is I'll just bring up JFK. They're going to be on southwestern Long Island. And this is constructed by a human forecaster, so this is going to get you very close to the kind of weather that they're expecting. And we can see here the gust highest they're expecting is 38 knots. That's going to be from about 5 to 9 Z, which is going to be around midnight to about 2 in the morning. And then some of the heaviest precip is found right there. You can see 1/4 of a mile in heavy snow winds gusting to 28 knots, and that's going to take place around 9 p.m. to midnight. And just checking around, you can see Philadelphia there. They're expecting it to start as snow and change over to snow with ice pellets, and then becoming rain briefly before becoming snow again. Now, another really good way to visualize this is to use this map right here and look at the graphical TAF. So I'm going to zoom in on that part of the country, and we're going to advance this up to about 2Z, which correlates to those models that we were looking at. So you can see that they're going mostly for snow in Pennsylvania. Got some ice pellets being reported there at Trenton. And Philadelphia, yeah, that's going to be rain right there. And by advancing this, you can kind of see the progression of the precip as the time groups for the TAFs change. And that can be very useful for predicting what kind of weather you're going to be seeing. Just to reiterate, again, those TAFs are created by humans, aviation weather forecasters at each Weather Service office. So those are going to be the lowdown on what they're expecting in terms of weather. So I would use those for any critical forecasting. And just going quickly through here, yeah, it looks like mostly snow and rain, and I'm just not really seeing much freezing precipitation. And that's a good thing because we don't want widespread power outages. So anyway, it looks like a lot of snow, and it should blow on out of here by tomorrow. And I think that's about all I want to cover for this edition of Forecast Lab. Hope you enjoyed it. So let me get this packaged and uploaded, and hopefully we'll get this to you very quickly. All right, take care, and we will see you tomorrow. Bye-bye.